what I kind of want to do in this video is go over the merge sort code, this merge sort pseudocode that we came up with in the last video, and also maybe make a few intuitive connections to it, and also see if we can make a few runs of this code and see what happens. And so from the last video, what we said was we defined this merge sort operation, or this merge sort method, where we're given D, which we thought of as a deck of cards, which is initially unsorted. And we said, let's look at this block here first, ignoring this if statement. We said first, we don't know how to sort a really big array of the size of D, right? D is presumably a large array that is all unsorted, and we have no idea how to sort it. What we did know is that if you split it in half, or if you split that deck D into two decks, sorted those decks, right, sorted those two decks, and then merged the result using our merge operation, then we could have a sorted array of the union of these two at the end. Right, and so we defined this block of code first, and then kind of realized that at some point merge sort is going to call merge sort, which is going to call merge sort, and it's going to keep calling it without stopping. And so we have to put a stopping condition on that. And that stopping condition, how we came up with it, came from the intuition that if we're given just a deck of cards of length 1, if we're given just one card, then we do know how to sort it, right? We just give that card back. One card by itself is trivially sorted already. And this is a tiny bit different from what I had before. I said before if the length of D is equal to 1. And now I'm saying less than or equal to 1 just to account for the fact that sometimes due to splitting in half and integer division, sometimes the length of the D that we get would be 0, right? And so in that case, if we're given nothing, then we just give nothing right back. Nothing is trivially sorted as well. And so let's try and think of this code right here as if we were going to call it. Let's do an example array actually. Let's say we had an array of length. Why don't we say 8? And we had 1, 8, 10, 2, 6, 4, 5. Is this length 8? No, it's not. Alright, let's put a 3 in here. Alright, let's just run through the merge sort code. I'm gonna try and go back and forth between these two screens as much as I can. But what's our first step? Well, I think you can go off of that code that we wrote before, but you can also go off of the intuition that we had, which was I have no idea how to sort this giant array, right? Let's say we've called merge sort on this array. Right, I have no idea how to sort this giant array. But I said if you split it in half and you could somehow sort these two smaller decks, then all I had to do was just merge them together, right? And so we've made these two calls in this tree that we're trying to build right here correspond with these two steps. And so likewise, we have this merge sort operation we have to do on this length 4 array. And we have no idea how to sort this length 4 array. But likewise, we do know if we sort this array and then we sort that array, all we have to do is merge them to get the sorted version of this. I'm going to do the same thing here. 6 and 4. These are all merge sort calls. I just wanted to save space and not write them. And then these are going to split themselves in half. Ooh, sorry about that. And they're going to call merge sort on these length 1 arrays. We're going to call merge sort on these length 1 arrays. And this, like we defined in our code, hits our base case, which was if that the length of our array was small enough, then we just trivially know that that array is sorted, right? We know the array of just one element is already sorted. And so it's a little bit important to know the order here, which is we started with this big call, and to solve this, we've called these 2 guys, and to solve these 2, we've called these 4 guys, and to solve these 4 guys, we called these 8. And so now I'm going to work my way back up, right? We've hit this base case where now we actually, in all these cases, we had no idea how to sort this array, how to sort these arrays. In this level, we know how to sort all of them actually. And so now we're going to work our way back up the tree. I'm going to use a different color here. Right, this array, we figured out merge sort on this, and so we're just going to return that. And we figured out the merge sort on this array, and we're just going to return that. And now we're just going to run the merge operation on these 2, right? And it just so happens that when we run the merge operation on these 2, this is the order of numbers that we get. I'm going to do the same thing here, right? We've called merge sort on 10. We know that 10 itself is sorted, so we return that. Likewise with 2. And so now we merge these 2 guys. And so in our merge operation, we said we're always going to take the smaller one first, right? We're always going to take the smaller one first. And so what we're going to see is that after the merge operation is complete, we get something like that. I'm just going to run through these because I'm sure you have the pattern by now. Right, and so this whole level had been waiting for a response, had been waiting to figure out how to sort their arrays. So now that we figured it out, now we can just return these sorted arrays. We're going to return these sorted arrays. Now we just have to merge this with this and this with this. So looking at these 2 arrays first, we're going to perform the merge operation and always look at the top. We're going to take this top, we're going to take this top because it's smaller, and now this top is smaller. I'm just performing the merge operation here, and then this top is smaller. Ugh. That's a 2. That right there is a 2. Same thing here, we're going to look at the tops of our 2 decks of cards. Always take the smallest one. Smallest one. The smallest one is 5, and then the smallest one is 6. And so this level had been waiting to sort their arrays, and now they've already figured out the answer. So now they get to return. And so now we can solve the original problem by taking these 2 subarrays which are sorted, and then running the merge operation onto them. So we're going to take a look at the tops of these 2 decks of cards. See that 1 is the smallest one, take that 1, take the 2, then take the 3. if it's not abundantly clear yet, I'm going to cross these out as we go. So we're going to take the 1, cross the 1 out, take the 2, cross the 2 out. Now we look at the tops. We take the 3. We look at the tops. We take the 4. At the tops, take the 5, then the 6, then the 8, and then the 10. And that is a run of the merge sort method.